Hi, once again, welcome to another Memrez discussion on YouTube. This time we are going to talk about plane areas by numerical integration. This time we're going to talk about the Simpsons rule. But before that, let us first discuss the basic of what is a plane area. A plane area is any bounded region like a square or perhaps a triangle. But what we are going to concentrate here is the finding of plane areas bounded by the rectangular coordinate system, the xy axis, with a given curve. A y is an f of x, and the boundaries we call A and B. So from here, we have drawn a figure with a boundary here that is not a straight line. So that our goal is to study methods wherein we will be able to determine the areas bounded by this curve here, this A and B, and the x-axis. So far, this will be the simplest plane area that we would study using the Simpsons rule. So what is the Simpsons rule? Now, the Simpsons rule actually is an approach, a brilliant approach by Simpson, that he thought of calculating the area bounded by a given curve and the x-axis given the boundaries A and B. So let's just call this A here, another boundary here B, so that this forms again a figure that we can determine the area. And Simpson thought of using a second degree polynomial in order to approximate this, but we're not going to talk about how he derived the formula, but rather we're just going to present here the things, the parameters that are necessary in order for us to apply this rule. Actually, this is a formula. So now, we have to know our boundaries A and B, but most importantly, we need to know our function. That is, our y is the f of x here. So that we are going to determine the heights of this A on the curve and with this B here. So what we are going to check if they are available would be, of course, the boundaries A and B and the average of this A and B, or the mean, which we just add as A plus B over 2, and that is somewhere here. So we need to determine these points on your x. So that is the A plus B over 2. Now next is to determine the height of A, that is its reflection on the y-axis. That is the y here, call it y1, or that y1 actually is the f of A here. And the height of our B, which we would call y2, That's the same height measured here or here. So that this y2 is really f of b. And the height of this a plus b over 2 is the f of a plus b over 2. Which, if we are able to evaluate these parameters, the formula for finding the area here, A, as approximated by Simpson, simply equal to the difference of these boundaries here, B minus A, multiplied to the heights. That is, the height on A, which is y1, plus 4 times the ym. So this is the height of the average. Call it ym. That's 4 ym plus y2. And we would like to take note that if you add the coefficients here, that's 4 plus 1 plus 1, and that would be the denominator of your b minus a. So this will be easier for us to memorize, because this 6 here actually is just the sum of the coefficients of our y's. So again, that's 4 plus 1 over 6. So we do not forget this easily, because we have something to associate with, and that is this area again is b minus a over 6 times the sum of the heights y1 plus 4 times ym plus y2, and that's the area. So we're going to use this by solving a problem. Our problem here is determine the area of a quarter circle whose radius is 6. That's the area of a quarter circle. Actually, this problem is purposely given because later on we can check for the area of this. So, how do we solve? Now, we are going to graph, and to simplify this, we are just going to consider the first quadrant of our circle, since we are dealing with a quarter circle, and it's our y and it's our x, such that suppose this is our circle, and the radius here is 6, so meaning this would be 6, 0 to 6 here, and so 0 to 6. So the equation of the circle, we know that is at center 0, 0 is x squared plus y squared equals to r squared. In that case, that is 6 squared, and that is equals to 36. And expressing this as a function of x, that is, our y can be calculated, any y, any height here can be calculated by the square root of 36 minus x squared. So as we choose our x here, we can calculate correspondingly our y. So we're going to use this later. Now, we're going to recall our Simpsons rule. It says that for boundaries A to B, we need to determine the average of these boundaries, and the respective heights. So if we are able to calculate these things, we can just plug it into the formula which we have already memorized here. Now, do we have our A? In this case, our A is 0. That's the center of the circle here. 0, 0. So we have a 0 A. But our Y here, Y1, would be the maximum or the radius on this point here. So that is our Y1 is equals to 6. Now our A plus B over 2 is just equal to 0 plus 6 over 2, which is equal to 3. Of course, that's the average, that's the halfway from 0 to 6 here. So this is 3. And B, which is 6. Our Y2 is 0. It's the radius that is lying on the x-axis. The height here is 0. Our height for our A plus B over 2, that is our YM, is really equal to the square root of 36 minus 3 squared. So that is the x, and this YM here corresponds to this x equals to 3 here. So our YM, can use our calculator, is square root of 36 minus 9. That's 3 squared, which gives us around 5.196. So that we are being supplied already by our A, B, the mean, the Y1, the YM, and the Y2. Our area now is just equal to, again, B minus A times quantity Y1 plus 4YM plus Y2 all over 6. So you can remember this because, again, that's the sum of the coefficients of our heights. 4 plus 1, 5 plus 1, 6. It's over 6 here. Wherein what we have is our B is 6 minus A, 0, all over 6 times Y1, which is 6 plus 4 times 5.196 plus 0, and our area is approximately, can use the calculator here, 4 times 5.196 plus 6 is approximately 26.784. That's around 27 square units. That is the area using the Simpsons rule. But as I said, we purposely choose a problem that involves a circle, a quarter of a circle, because later on we can check our result here using the formula, since we know already. This is just for the purposes of illustrating the Simpsons rule. That is, the area of a quarter circle is a pi over 4 r squared. So we know the r, that's 6 squared over 4. So this gives us times 28.274. That is approximately. So you notice here that there is that difference. Of course, the Simpsons rule is an approximation tool, so that for other graphs, this can be handy, a practical way of approximating areas. So we have here the area, and this ends our discussion. So thank you for watching, guys. Kindly check us out for our next video presentation. Thank you for watching.